Consider the functions f, g, and h defined as follows for t is real. Question A shows that h of t is the imaginary part of such a complex number. So how this sign is related to complex number? We know that a complex number in modulus argument form looks like modulus r multiplied by cosine over theta plus I sine of theta, where theta is the argument, and the same but in the Euler's form or in the exponential form looks like r multiplied by e to the power I theta. And sine of 2t plus 1, it looks like a part of a complex number. What a complex number? 1 multiplied by cosine of 2t plus 1 plus I sine of 2t plus 1, and we have sine, and it's with I, so it's the imaginary part. If it would be given cosine, so it's the real part. Cosine is the real part, sine is the imaginary part. So sine of 2t plus 1, it's the imaginary part of such a complex number, and we need in the Euler's form or in the exponential form, so its modulus is 1 here, it's just number in front, it's 1, and e to the power of I multiplied by 2t plus 1. And absolutely similarly, sine of 2t plus 3 is the imaginary part of e to the power I 2t plus 3. Hence, h of t becomes the imaginary part of e to the power of I multiplied by 2t plus 1 plus the imaginary part of e to the power of I multiplied by 2t plus 3, and the imaginary plus the imaginary, it will be also the imaginary part of e, and you can see that we need just factor out e to the power of 2ti, so it becomes the imaginary of e to the power of 2ti multiplied by e to the power of I. It's like 2 to the power of 3 plus 5, it's 2 to the power 3 multiplied by 2 to the power of 5, and plus e to the power of 2ti multiplied by e to the power of 3i, and it becomes the imaginary part of e to the power of 2ti and multiplied by e to the power of I plus e to the power of 3i as required. And we do this step because this can be calculated with a calculator, and this cannot be calculated with a calculator because if there is a t, calculator doesn't work. There must be numbers and I only. Hence, e to the power of I plus e to the power of 3i can be calculated using a calculator, and we need, since it is given that theta is from negative pi to pi, it means that theta is in radians. So first of all we need radian mode, then we choose this complex numbers in the Euler's or in the exponential form, and just e to the power of I plus e to the power of 3 I, and we get the answer also in the Euler's form. So it becomes 1.08 to 3 significant figures times e to the power of 2I. Theta must be from negative pi to pi. Pi is 3.14, so it must be from negative 3 point something to 3 point something. So you can see that e to the power of theta I, theta is 2, so it's greater than negative 3 point something and less than 3 point something. So it's correct. The next. And in general, if you add or subtract any number of full revolutions, any number of 2 pi, it's an equivalent. If we add or subtract to the argument any number of 2 pi or 360, if it is measured in degrees, it's absolutely the same, because it's absolutely the same point and same xy coordinates on the organ diagram, so it's absolutely the same complex number. Hence, question C, write h of t in the form. So we continue, so it becomes h of t is this, this is calculated and it is equal to this, so it becomes the imaginary part of e to the power of 2ti and multiplied by this 1.08 times e to the power of 2i, and again it's a product of two powers, so it is equal to the imaginary part of 1.08 times e to the power of 2ti plus 2i, and it's clear that it's 2t plus 2 multiplied by I, and the imaginary part of such a complex number, it's again sine, so it's 1.08 times sine of 2t plus 2. And we can see that it becomes p times sine of 2t plus q. P is positive and q is in between 0 and 2 pi. So 2 pi is 6.28 and it's plus 2. Definitely it's from 0 to 2 pi, so it's true. And that's all for this question.